In this video, I'm going to go through the steps to testing the hypothesis that hedonism might change across time. So this is self-report hedonism by young adults. I believe they were in their 20s to 30s. And at 3 different time periods where 4 years apart, people self-reported their hedonism levels. And I've simulated the data to correspond to the results that was published in the study. And for those who don't know what hedonism is, just to make sure we're all on the same page, it's the pursuit of pleasure and sensual self-indulgence. We got the pursuit of pleasure and self-indulgence measured at 3 different time periods. And we can go through our trusted checklist to check to see that the dependent variable is measured on some kind of continuous scale. And we can see that it does look like it's a continuous scale of some sort. I actually can't remember if it's a 1 to 10 scale. It could be 1 to 10. It looks like it's certainly continuous and certainly at least ordinal with more than 5 points. So we got a check mark there. I think the data are sufficiently continuous for doing a repeated measures ANOVA. And so I'm going to give a check mark for that. And now we've got number of levels, 3 levels. So I can do a potential protected Fisher's LSD as a possibility. I don't have to do the Bonferroni. That's what I'd have to do if I had more than 3 levels. How about normality and outliers? Well, let's check that quickly. Put all 3 levels into the dependent list, plots, deselect histogram, and statistics, and outliers, and click OK. And here are the skew and kurtosis levels, less than 2 and 9. Less than 2 and 9 respectively, and less than 2 and 9 respectively across hedonism time 1, hedonism time 2, and hedonism times 3. So the data are sufficiently normally distributed. Here we have some very nice normally distributed data, no outlier based on this. This is a warning case. It doesn't have an asterisk. I'm not surprised there's no outlier. This looks a bit outlying, but it actually wasn't identified as an outlier based on the interquartile range rule. With a 3.0 multiplier, it wasn't. It's just a 1.5 multiplier, which is just a warning. I wouldn't take it seriously. And so we've got normally distributed data. We don't have any outliers. So let's get a check mark for that. And check sphericity. Well, we can check that once we do the analysis, which we're going to do a one-way repeated measures ANOVA. And we've got 3 time periods. And define, we'll put our 3 time periods here, and we'll click on options. We want to do the Fisher's LSD, assuming the sphericity assumption will be satisfied. Descriptive statistics, effect size, continue, and plots. Put the horizontal axis there, add it here, and click OK, and let's see what happens. So we've got hedonism levels. Looks like they're staying about the same from the first time period in the 20s to the second time period. And then they look like they might drop 4.57 down to 4.47. Don't know if that's statistically significant or not. There's numerical differences, but I have to say there's not much in the way of difference here. Overall sample size of 107 for this within subjects design. So again, this isn't 107 for each group, but there's really just one group here, 107 people giving ratings 3 times in their life. And we've got the Machlis-Tessa sphericity. Oh, we've violated the assumption this time. Hunfeld is 0.87, so it's less than 1.0, which is suggesting there's some deviation across the standard error, the difference between the means across comparisons, and it's statistically significant. So I need to look only at the Hunfeld. I got to skip sphericity assumed, and actually we've got the Hunfeld analysis with an f-value of 0.987 and a p-value of 0.365. And the eta squared is 0.009. Very, very small effect size. It's also not significant statistically. So let's look at the planned comparisons. Not that we should. I mean, we haven't found a significant effect with the omnibus ANOVA. We're very unlikely to find anything with the multiple comparisons. Least significant difference. Look at all these p-values. Nothing is less than 0.05. So none of the comparisons between the mean levels of hedonism across age are statistically significant. So let's look at the plot. Well, it looks like something a little bit bizarre, doesn't it? It looks like hedonism is increasing from time 1 to time 2, and then it decreases to time 3. But if we actually put this on a 10-point scale, let's assume that's what it was measured on. Let's say it was measured on a 1 to 10-point scale. Then this is really what it looks like. So SPSS really made it look like it might be something quite unusual and something significant, but when you look at it at this level, there's really nothing going on with these data. So this is an important point. So even if the scale was a 1.1 to 7 scale, say, I can't remember what the scale was, but even if it was 1 to 7, we still don't have anything going on there. There's really not much going on. So what about the contrast analysis? If we're going to squeeze as much power out of this analysis, we do a contrast. Realistically, you could only back up theoretically a linear effect. Either hedonism is going down across time or it's going up. Once people are adults, you don't expect some kind of up and down sort of thing going on, which would be a quadratic effect. It doesn't matter. Neither of them is statistically significant. So as far as hedonism is concerned, for this period in people's lives, which from memory was in the 20s and 30s, hedonism is not changing. It's staying about flat. And we can't accept the null hypothesis, but we certainly cannot reject the null hypothesis in this study. And we did have to be careful because we did violate the mutually excessive sphericity, but we just relied on the Hunfeld results, which really weren't that different from the sphericity assumed anyway. But as a rule, you should follow that. So I've checked sphericity, and I've conducted the ANOVA with the multiple comparisons, which were protected Fisher's LSD. I did look at the effect size for the omnibus ANOVA, which was 0.009, very small effect. I would report it anyway in a manuscript or a thesis. You should always report the effect size for an analysis. And if you did the multiple comparisons, you would calculate Hedges G for each of those comparisons. Of course, I cover Hedges G in another chapter. I'm not going to redo that here. And I've shown you a graph, and importantly, I adjusted the graph so that it would be reflective of what is actually going on, rather than making a really narrow band and accentuating some kind of small difference and making it look like something big. That would be inappropriate. So that is the solution to the practice question about hedonism across time.